What happens when the very machines designed to save us become the cause of disaster? In the modern skies, pilots and passengers alike put their faith in automation. Complex computers that can calculate, monitor, and fly with a precision no human can match. But what if those systems fail? What if, in the critical moments, the technology we trust blindly misreads, miscalculates, or simply overrides human instinct? Welcome to Air Crash Decoded, the place where we uncover not just the tragedies of aviation, but the extraordinary lessons hidden inside them. Today, we step into one of the most unsettling questions of modern flight: when computers fail. These are the crashes that challenged our belief in automation, the incidents that forced the aviation world to ask, who is really in control? The pilot or the machine? The rise of automation. The story of flight has always been a story of progress. From fragile wooden wings to supersonic jets, aviation has been defined by constant innovation. Each breakthrough promised not only greater speed and distance, but above all, greater safety. By the late 20th century, one innovation stood above all others: computer-assisted flight. Automation was hailed as the revolution that would end aviation accidents caused by human error. Autopilot could fly the aircraft with unshakable precision. Autothrust could control engine power better than any human hand. And fly-by-wire technology could prevent the plane from exceeding dangerous limits. Airlines embraced these systems because they made flight smoother, more fuel-efficient, and statistically safer. But as computers took over more of the workload, something subtle began to change inside the cockpit. Pilots, once masters of their craft, began to take on a new role. Not active aviators, but monitors of machines. Their hands touched the controls less frequently. Their instincts, once honed through constant manual flying, grew weaker with each passing generation of aircraft. On paper, this seemed like progress. Less human error, more computer stability. But reality was more complicated. For while machines can process numbers faster than any human, they cannot think. They cannot improvise in chaos. They cannot distinguish between a faulty reading and reality. And in aviation, chaos comes quickly. When sensors freeze, when switches are misset, when hidden software behaves in ways no pilot expects, the carefully constructed partnership between human and machine begins to unravel. Suddenly, pilots who have been taught to trust automation find themselves fighting against it, or worse, utterly confused by it. The result is tragedy, and each tragedy tells the same uncomfortable truth. Automation is powerful, but it is not invincible. In the coming stories, we will step into the cockpits of 3 infamous flights where the failure of automation didn't just cause confusion, it cost lives. Flights that showed the world that technology can guide us, but it can also betray us. Case 1. Air France 447, The Atlantic Mystery. On June 1, 2009, Air France Flight 447 departed Rio de Janeiro, bound for Paris. On board the Airbus A330 were 228 souls, passengers and crew expecting an overnight flight across the Atlantic. The A330 was considered one of the safest aircraft in the skies, packed with advanced automation and layers of protection. For hours, everything seemed normal. The passengers slept, the cabin was calm, and the autopilot guided the jet effortlessly through the night. But high above the Atlantic, nature had set a trap. Ahead lay towering thunderstorms, the kind that rise out of the tropics like mountains of lightning and turbulence. The crew adjusted their path to avoid the worst of it, but they could not escape entirely. Then in the thin, icy air at 35,000 feet, something small but deadly happened. The pitot tubes, the tiny sensors that measure airspeed, began to freeze. It was a problem Airbus engineers had warned about before, but on this night it became catastrophic. When the sensors froze, the computer no longer had accurate speed readings. Autopilot, designed to disengage in such conditions, suddenly clicked off. Alarms sounded. The pilots, who had been monitoring calmly for hours, were thrust back into manual control of a massive jet in the middle of a violent storm, with instruments that no longer made sense. Confusion spread quickly. The cockpit filled with contradictory warnings: overspeed, stall, unreliable airspeed. The protections that normally prevented pilots from making dangerous inputs shut down. Instead of guidance, they had chaos. The co-pilot pulled back on the side stick, believing the aircraft needed to climb. But without realizing it, he forced the jet into a high-altitude stall. The nose pitched up steeply, speed bled away, and lift vanished. The Airbus, a machine designed to soar, was now trembling on the edge of aerodynamics it was never meant to face. At 2:14 a.m., the A330 slammed into the ocean at over 10,000 feet per minute. The sea swallowed everything. For years, the wreckage remained hidden, 4,000 meters below the surface. When investigators finally recovered the black boxes, the truth became clear. Automation's sudden handover, combined with human confusion and training gaps, had turned a manageable problem into a catastrophe. Air France 447 was more than a crash. It was a lesson written in the darkest ink. It revealed how over-reliance on computers and a lack of raw flying skills in rare but critical moments could bring down even the most advanced aircraft. 28 lives were lost, but their legacy reshaped aviation. Airlines around the world reevaluated training, focusing once again on manual flying skills. Pilots were reminded that behind the screens and systems, they must always remain aviators. The Atlantic mystery was solved, but the warning it carried was universal. When automation falters, human judgment must rise. Case 2. Asiana Airlines Flight 214, San Francisco shock. On July 6, 2013, a bright summer morning dawned over San Francisco. Asiana Airlines Flight 214, a Boeing 777, approached the city after a long journey from Seoul. On board were 307 people, many of them excited for their arrival in the United States. The Boeing 777 was considered a marvel of safety and reliability, boasting one of the best records in aviation history. For years, it had flown millions of passengers without a single fatal accident, but that reputation was about to be shattered in a way no one expected. As the aircraft descended towards San Francisco International Airport, visibility was clear and weather calm. Conditions, in fact, seemed perfect. Yet inside the cockpit, a deadly misunderstanding was unfolding. The crew believed the autothrottle, a system that automatically manages engine power, was engaged. They assumed it would hold the aircraft's speed steady as they glided down to the runway. But in reality, the autothrottle was not working in the mode they thought it was. Instead of maintaining thrust, it idled the engines. At first, the crew didn't notice. The 777 continued descending smoothly, but slowly, dangerously, its speed was bleeding away. Pilots, distracted by the approach path and their own reliance on automation, failed to realize the jet was sinking below the safe glide slope. Seconds ticked by. At just 500 feet, a stick shaker, a warning of an impending stall, should have been the final wake-up call. But by then, the aircraft had lost too much energy. Suddenly, alarm screamed in the cockpit. Realizing the disaster, the pilots yanked the nose up and pushed the throttles forward. But jet engines cannot produce power instantly. They need time to spool up. With the runway rushing closer, time was the one thing the crew didn't have. At 11:27 a.m., the tail of the Boeing 777 struck the seawall just short of the runway. The impact ripped the tail section from the fuselage, sending debris scattering across the approach path. The aircraft skidded violently along the ground, broke apart and burst into flames. Panic erupted as passengers scrambled to escape. Miraculously, of the 307 on board, 304 survived. But 3 young passengers lost their lives, and nearly 200 suffered injuries, some severe. The images of a modern jetliner in flames on American soil shocked the world. How could such a reliable aircraft fail on a clear day, in perfect weather during a routine landing? The investigation revealed the uncomfortable truth. The aircraft had not failed. The humans had. The crew had placed too much trust in automation. They misunderstood how the autothrottle functioned, believing it was guarding their speed when it was not. Their manual flying skills were rusty, their situational awareness dulled by years of leaning on the computer. By the time they realized their error, the physics of flight had already closed the window of recovery. Case 3. Boeing 737 MAX, a system gone rogue. In October 2018, Lion Air Flight 610 took off from Jakarta, Indonesia. Just minutes later, the Boeing 737 MAX plunged into the Java Sea, killing all 189 people on board. Barely 5 months later, in March 2019, Ethiopian Airlines Flight 302 suffered the same fate, crashing near Addis Ababa and claiming 157 more lives. 2 brand new airplanes, 2 horrifying crashes, and one question that stunned the world. How could Boeing's newest jet, advertised as safer and more efficient than ever, bring such devastation? But here was the problem: pilots weren't fully informed about MCS. Many didn't even know it existed. Worse, the system relied on a single sensor, the angle of attack vane, to decide whether to activate. If that sensor failed or gave faulty data, MCAS could trigger incorrectly. And that's exactly what happened. On Lion Air 610, the sensor sent false signals that the nose was too high. MCAS responded by forcing the plane's nose downward. Pilots fought back, pulling up, but MCAS kept re-engaging, driving the jet into a deadly tug-of-war. Within 13 minutes of takeoff, the aircraft slammed into the sea at terrifying speed. The same nightmare repeated with Ethiopian Airlines 302, despite global awareness of the earlier crash. Once again, faulty sensor data activated MCAS, and the system relentlessly forced the nose down. The crew fought desperately, but their training had not prepared them for this hidden feature. Within 6 minutes, the jet was gone. The shock was global. How could a system override experienced pilots and doom 2 modern aircraft? Investigations uncovered damning evidence. Boeing had minimized MCAS in manuals to speed up certification, assuming pilots didn't need to know the details. The company wanted airlines to see the MAX as just another first-in requiring no expensive simulator training. But this decision came at the cost of transparency and safety. Public trust in Boeing collapsed. Regulators grounded the entire 737 MAX fleet worldwide for nearly 2 years, the longest grounding in aviation history. During that time, engineers redesigned MCAS, adding redundancy, safeguards, and training protocols. But the damage to Boeing's reputation and the grief left behind by the victims' families could never be erased. The lesson was harsh. Automation can be powerful, but when hidden, misunderstood, or poorly designed, it can become a lethal trap. The 737 MAX crisis wasn't just about software. It was about accountability, corporate pressure, and the balance between human pilots and the machines they command. The tragedies of Lion Air 610 and Ethiopian 302 remain chilling reminders that progress in aviation cannot come at the cost of clarity and honesty. When computers fail, they don't just fail silently. They fail with catastrophic consequences. Lessons from failure. The skies have always demanded respect. From the earliest wooden planes to today's advanced jets, every innovation has carried both promise and peril. The crashes of Air France 447, Asiana Airlines 2014, and the Boeing 737 MAX teach us that while automation can save lives, it can also challenge the very instincts and judgment humans rely upon. First, automation is not infallible. A frozen sensor, a misunderstood system, or a hidden software feature can unravel layers of technological safety in an instant. Air France 447 showed that even the most sophisticated aircraft could stall if pilots were left to interpret conflicting signals in the dark, turbulent skies. Asiana Flight 214 reminded the world that over-reliance on automation, combined with a lack of manual skill, can turn a routine landing into a disaster. The 737 MAX tragedies highlighted the dangers of hidden systems and corporate decisions that prioritize efficiency over transparency and human awareness. Second, human skill is irreplaceable. Pilots must be more than supervisors. They must be aviators, capable of stepping in when computers falter. Systems can calculate, monitor, and react, but they cannot think critically under chaos, improvise solutions, or adapt instincts to circumstances the designers never anticipated. Third, transparency matters. Crews must understand the systems they operate. Hidden features, incomplete manuals, and assumptions that humans will figure it out can be deadly. Training, knowledge, and clear communication between manufacturers, regulators, and pilots are essential to keeping the skies safe. Ultimately, these tragedies reveal a timeless truth. Technology is a tool, not a replacement for human judgment. Computers can guide, assist, and protect, but the final decisions, especially in moments of crisis, remain in human hands. Courage, clarity, and experience make the difference between survival and catastrophe. As we reflect on these events, it's clear that progress in aviation carries responsibility. Each crash, each investigation, and each lesson learned contributes to a safer future. The balance between man and machine is delicate, but when respected, it creates a partnership capable of extraordinary achievements. You've been watching Air Crash Decoded. If this journey into the failures of automation gave you insight or raised questions about the trust we place in technology, share it, discuss it, and carry the lesson forward. Like this video if it impacted you, and subscribe to join us as we uncover the next chapter in aviation history. Because in the world of flight, every lesson written in loss is a lesson that keeps the rest of us alive. Technology may guide the plane, but humans guide its destiny.